In November 2024, an extraordinary and significant submarine volcanic eruption began at Aik Mount, a massive underwater volcano situated near the Mariana Trench, which is the deepest known part of Earth's oceans. The eruption caught the attention of the scientific community due to the scale and complexity of the event, as well as its location in one of the most tectonically active regions on the planet. As the eruption unfolded, the surrounding ocean waters were visibly affected, with large discolored plumes of water rising to the surface, likely accompanied by floating pumice, a volcanic material formed from rapidly cooled lava. This visible evidence of volcanic activity underscored the ongoing dynamic changes occurring beneath the ocean's surface. The eruption was significant enough for the Northern Mariana Islands Volcano Observatory to take swift action, raising the volcano's alert status to advisory and the aviation color code to yellow, signaling increased volcanic activity. This designation indicated that while the immediate risks to human life were considered minimal, the eruption had the potential to cause regional disturbances, particularly in maritime navigation. The eruption's location, being so far from major human populations, minimized the risk to life and property, yet it highlighted the unpredictability and immense power of the geological forces at work. In the days and weeks following the eruption, scientists continued to monitor the event closely to understand its full scope and implications, knowing that such volcanic activity could have far-reaching effects on both the immediate environment and the broader tectonic systems at play. Aik Mount is no ordinary volcano. It is a colossal submarine volcano, one of many that make up the Mariana Volcanic Arc, a chain of volcanic islands and seamounts that stretches across the western Pacific Ocean. Situated approximately 18 kilometers southeast of the island of Farallon de Pajaros in the northern Mariana Islands, Aik Mount is an imposing feature beneath the ocean's surface, rising from the seafloor to within 75 meters of the water's surface. Despite its massive size, it has not yet breached the surface to form an island. However, its persistent volcanic activity suggests that this could be a future possibility. Over millions of years, the eruptions at Aik Mount have played a significant role in shaping the underwater landscape, and this eruption is just the latest chapter in its geological history. The underlying tectonic processes at work in this region are part of a larger, complex system of plate movements and subduction zones. The Mariana Trench is the site of one of the most intense subduction zones on Earth, where the Pacific tectonic plate is slowly sliding beneath the Philippine Sea Plate. As the Pacific Plate is forced downward into the mantle, immense heat and pressure are generated, causing the release of water and other volatiles from the subducting plate. These materials interact with the mantle above, lowering its melting point and triggering the formation of magma. The magma, which is less dense than the surrounding rock, rises to the seafloor, eventually leading to the formation of underwater volcanic features like Aik Mount. The eruption that began in August 2024 has drawn significant attention, not only for the scale of the event but also because it presents new challenges in the study and monitoring of submarine volcanoes. Unlike land-based volcanoes, which can be monitored through seismic stations, ground-based instruments, and visual observation, underwater volcanoes are notoriously difficult to study. Their remote locations, often in deep oceanic trenches, and the technical limitations of existing monitoring tools make it challenging to obtain detailed and accurate data. In this case, scientists have employed advanced technologies such as satellite imagery and remote hydrophone systems to monitor the eruption. Hydrophones are sensitive instruments designed to detect underwater sound waves produced by volcanic activity. However, the hydrophones monitoring Aik Mount have not registered any significant signals. This could be due to the nature of submarine eruptions, which often produce large visual plumes without generating strong acoustic signals. The absence of significant acoustic signals from Aik Mount highlights one of the major challenges of studying underwater volcanic eruptions. While satellite imaging is extremely useful for tracking changes in water temperature, color, and surface disturbances, it cannot provide the level of detail that a ground-based seismic network could offer. Similarly, hydrophones are valuable tools for detecting seismic events beneath the ocean, but their utility is limited when eruptions do not produce the expected sounds. Despite these limitations, scientists have managed to gather valuable data about the eruption by relying on a combination of these tools, which together provide insights into the volcano's ongoing activity. Monitoring underwater volcanoes requires a multifaceted approach, combining visual, acoustic, and thermal data to build a comprehensive picture of the eruption. The challenges of studying Eyck Mount are not limited to the technological limitations of monitoring equipment. The volcano is also located in a particularly inaccessible area of the ocean, making it difficult for scientists to conduct direct observations. While terrestrial volcanoes benefit from the availability of seismic networks, local monitoring stations, and easy access for fieldwork, submarine volcanoes require more sophisticated technologies and often rely on remotely operated vehicles, ROVs, or autonomous underwater vehicles, AUVs, to gather data from the seafloor. In the case of Eyck Mount, the lack of local seismic stations and the remote nature of the volcano mean that scientists are unable to study it in the same way as they would a land-based volcano. This isolation makes it harder to assess the full impact of the eruption on the surrounding environment and to predict future volcanic behavior. Despite its remote location, Eyck Mount's activity has important implications for human activities in the region. Submarine volcanic eruptions can release significant amounts of volcanic debris into the ocean, which can float to the surface in the form of pumice or other volcanic materials. This floating debris can pose a hazard to maritime navigation, potentially damaging ships or disrupting shipping operations. Additionally, the release of gas bubbles or ash plumes into the water can affect the surrounding marine ecosystem, altering water chemistry and impacting marine life. Mariners in the region are advised to take precautions and avoid areas where floating debris or ash plumes may be present, as these hazards could cause significant disruptions to shipping lanes and fishing. Activities, Eyck Mount's history of eruptions, provides further insight into the volcano's dynamic nature. Previous eruptions, such as those in 1979, 2001, and 2014, have dramatically reshaped the seamount structure. In 1979, a fishing crew reported unusual vibrations near the summit, followed by the upwelling of sulfur-laden water. The 2001 eruption, which was detected through seismic activity recorded hundreds of kilometers away, highlighted the importance of monitoring remote volcanoes using advanced seismic networks. More recently, the 2014 eruption created a new summit, crater, and caused a landslide on the southeastern flank of the seamount. These past events demonstrate how underwater volcanic activity can lead to significant changes in the seafloor, reshaping the landscape and creating new geological features. The recurring volcanic activity at Eyck Mount emphasizes the importance of continued observation and research. The seamount's geological setting, marked by the subduction of the Pacific Plate beneath the Philippine Sea Plate, makes it an active hotspot for volcanic eruptions. These processes drive the formation of magma, which periodically rises to the surface, resulting in the construction of new volcanic features. Over time, repeated eruptions at Eyck Mount have built up layers of volcanic rock, forming the towering seamount that exists today. While the summit remains below sea level, ongoing eruptions suggest that the volcano could eventually breach the surface, creating a new island in the future. Studying Eyck Mount provides valuable insights into the larger processes of submarine volcanism and the tectonic dynamics of subduction zones. The activity at Eyck Mount serves as a natural laboratory for scientists to study the interactions between subduction, volcanic activity, and seafloor spreading. The continuous eruptions at Eyck Mount also offer a glimpse into the processes that shape the Earth's crust over millions of years, providing a deeper understanding of the forces that drive plate tectonics and the creation of new oceanic crust. In conclusion, the eruption of Aik Mount in November 2024 serves as a powerful reminder of the immense and largely unexplored geological forces at work beneath the ocean surface. As a part of the Mariana volcanic arc, Aik Mount continues to captivate scientists. With its dynamic activity and transformative volcanic processes, this eruption not only sheds light on the inner workings of submarine volcanoes, but also underscores the importance of monitoring and understanding these phenomena to mitigate potential risks to maritime operations and marine ecosystems. The study of Aik Mount offers valuable lessons in the complexities of volcanic activity, particularly in remote and difficult-to-access locations, and highlights the need for continued technological advancements to better monitor and predict underwater eruptions.